This is the proof for the second proof for the Pythagorean theorem. In this proof, we start with four triangles. And we note that the area of the one triangle is 1/2 the base times the height. Our base is A, our height is B, so it's 1/2 AB. We have four triangles, so 4 times the area of the triangle is 4 times 1/2 AB, and that gives us 2AB. Once we have that established, we can arrange the triangles, and we want to put them in this particular order. And what we have created here is a square this big, and we can see that each side has length C. So we have the big square, and its sides are length C. So we have the area of the big square, we'll call it square sub 1, that's going to be C squared. And we also have a little hole in our big square. And if we think about the dimensions of the hole, we see that it's this length B subtracted off that length A gives us that length for the side of the hole. And that's true for each side. So the sides of the hole have length B minus A, which means that the area of the hole, so let's call it square sub 2, that's the hole, is B minus A squared. And because you remember your algebra, you know that this is B squared minus 2AB plus A squared. Now, what we want to see is how do we get the Pythagorean theorem out of this? We recognize we have these three different areas and they're all related in this picture. We know that the area of the big square, that's our sub 1, is going to be equal to, no, let's write it this way. The area of the big square minus the area of the little hole is going to be equal to the area of the four triangles. It's this big piece, that's the area of the big square. If we subtract off the area of the hole because we've removed area from it, then what we are left is the area that's in white here, and that is equal to the area of the four triangles. Let's fill in the numbers. Area of 1 is C squared. The area of the hole is B squared minus 2AB plus A squared, and that's equal to 4 times the area of the triangle, which is 2AB. And now we do some algebra. We need to distribute the minus sign across. We get C squared minus B squared plus 2AB minus A squared is equal to 2AB. We know that these two cancel out because they're the same quantity on other opposite sides of the equal sign. And we can also move these two negative values or subtracted values over to the other side of the equal sign, and we get C squared equals A squared plus B squared. We have proved what we have set out to prove. If you use this proof for the one that you memorize, what you need to do is trace these four triangles down. You need to label all of the parts, the A, B, and C for each one of the triangles. you need to then write down that the dimensions of the whole are b minus a. That's why you have to label all the parts on the triangles, because that's the only way it shows that the side length of the whole is b minus a. Once you have that, then you go through and you write down all of the algebra, and you're done.